Hello guys, welcome to Apex Math. My name is Pino. In this video, we use the techniques of partial fraction decomposition to evaluate question 3 from the April 2025 N6 Mathematics question paper. Question 3.1, in the denominator, the 3x plus 1 is repeating itself 3 times because it's raised to the power 3. So we have repeated linear factors. So we simplify this according to the methods of repeated linear factors before we can integrate. So we forget about the integral and the dx for now and focus on simplifying our integrand. The decomposition of this linear repeated factor will be equals to a divided by 3x plus 1 plus b divided by 3x plus 1 raised to the power 2 plus c divided by 3x plus 1 raised to the power 3. Since the 3x plus 1 is raised to the power 3, this is where we will stop with the decomposition and determine the numerical value of a, b, and c. We determine the numerical value of a, b, and c. The first step is for us to multiply both sides of the equation by the 3x plus 1 raised to the power 3. So that we can cancel that 3x plus 1 raised to the power 3 in the denominator. So we multiply by 3x plus 1 raised to the power 3, both sides of the equation. And on the left hand side, the 3x plus 1 raised to the power 3 will divide and be equal to 1, and will be left with 3x squared minus 4x plus 5, and now we distribute the 3x plus 1 raised to the power 3 inside the parentheses. And we will have a divided by 3x plus 1 multiplied by the 3x plus 1 raised to the power 3 plus b divided by 3x plus 1 squared multiplied by the 3x plus 1 raised to the power 3 plus c divided by 3x plus 1 raised to the power 3 multiplied by the 3x plus 1 raised to the power 3. And this will be equal 3x squared minus 4x plus 5 equal, so that 3x plus 1 will divide with one of the 3x plus 1 and will be left with two of them, and even there will be left with 1, but here the 3x plus 1 to the power 3 will cancel out. Now we have a into 3x plus 1 raised to the power 2 plus b multiplied by 3x plus 1, and here we'll be left with just the constant c. We have three unknowns a, b, and c, so we have to set up three equations based on this chief equation. In constructing the three equations which will help us determine a, b, and c, we can let x be any number. Whatever number that we choose has to be plugged in on the left and the right side of the equation, and there are specific numbers that when we choose will make our efforts a little bit easier. For example, if we choose x is equals to negative 1 divided by 3, when we substitute the x is equals to negative 1 over 3 there, 3 multiplied by negative 1 over 3 will be negative 1 plus that 1. And negative 1 plus 1 will be 0. Same applies to that term there. The 0 multiplied by that a will be 0, and even multiplied by that b will be 0. So we select x is equals to negative 1 over 3. So we have 3 multiplied by negative 1 divided by 3 in the place of the x squared minus 4 multiplied by a negative 1 divided by 3 plus 5 is equal, so a multiplied by 3 multiplied by negative 1 divided by 3 plus 1 squared plus b multiplied by 3 multiplied by negative 1 divided by 3 plus 1 plus the c. On the right hand side, the whole thing will be equal 20 divided by 3, and this will be equal, so like I said, the 3 multiplied by negative 1 over 3 will be negative 1. Negative 1 plus that 1 will be 0. 0 multiplied by a will be 0. Same applies to the b term. That 3 multiplied by negative 1 over 3 will be negative 1. Negative 1 plus 1 will be 0. 0 multiplied by b will be equals to 0. So we are left with the c, which will be equals to 20 divided by 3. Now we have to determine a and b. We can be strategic and choose numbers which are small. So we can choose x is equals to 0. And when we choose x is equals to 0, any number multiplied by 0 will be equals to 0. So on the left hand side, since we chose x to be 0, on the left hand side we have 5, which will be equal a into 3 multiplied by 0 is equals to 0. So we'll be left with 1 squared. But 1 squared is equals to 1. So even with the b, 3 multiplied by 0 will be 0 plus 1. So b multiplied by 1 will be b plus our c, which we determined to be 20 divided by 3. We end up with 5. We move the 20 divided by 3 to the left. It will change sign to negative 20 divided by 3. And also move the b, and we have negative b also in the left, and this will be equal a. 5 minus 20 divided by 3 is equal negative 5 divided by 3 minus b is equals to a. So now we construct another equation by choosing x equal any number. So we target the smaller numbers, so we choose x to be equals to 1. And the 3 multiplied by 1 will be 3, minus 4 multiplied by 1 will be 4. So we have 3 minus 4 plus 5, which will be equal a into 3 multiplied by 1, which is equals to 3 plus 1 raised to the power 2 plus b multiplied by 3 by 1 is equals to 3 plus 1 plus the c. So 3 minus 4 plus 5 on the left hand side will be equals to 4, which will be equals to, so 3 plus 1 squared will be 16. So we have 16 multiplied by a plus 4 multiplied by b. And our c was equals to 20 divided by 3. So let's substitute the 20 divided by 3 for c. On our second equation, we determined a in terms of b. So in the place of that a, we will substitute negative 5 over 3 minus b. So we have 4 equal 16 multiplied by a, but in the place of the a, we have negative 5 divided by 3 minus b plus 4b. We can move that 20 divided by 3 to the left. It will change sign to negative 20 divided by 3. Negative 20 divided by 3 plus 4 will be equals to negative 8 divided by 3. This will be equals to 16 multiplied by negative 5 over 3, which is equals to negative 80 divided by 3. 16 multiplied by negative b, which is negative 16b, plus 4b. We have negative 8 divided by 3. We move the negative 80 divided by 3 to the left. It will change sign to positive 80 divided by 3. And this will be equal negative 16b plus 4b, which is negative 12b. Negative 8 over 3 plus 80 over 3 is equals to positive 24. And this will be equals to negative 12b. Dividing both sides of the equation by negative 12, our b will be equals to negative 2. Now we determine the numerical value of a. We are only left with the a, and our a was equals to negative 5 over 3 minus b in the place of the b. We are going to substitute negative 2. Negative 5 over 3 minus 2 will be equals to positive 1 over 3. Now we have our a. Our a is equal positive 1 divided by 3. So now that we have the a, we also have the b, and our c was equal 20 divided by 3. We can now substitute these constants into the original equation. Remember that integrating the left hand side with respect to x is the same as integrating the right hand side. So let's integrate the right hand side since we already know the values of a, b, and c. So this will be equal the integral. So we have the 3x plus 1, and our a is equals to 1 divided by 3, and we have that 3x plus 1 raised to the power 2, and our b is negative. So let's write this one. So we have also the 3x plus 1 raised to the power 3. Since the b is negative, we have that negative there, negative 2, and our c is equals to 20 divided by 3. We are integrating with respect to x. To integrate, we can use the u-sub method, where we let u equal 3x plus 1, differentiating the u with respect to x. The derivative of the 3x is equals to 3, and the derivative of that one is 0. We multiply both sides of the equation by dx, and that dx and that dx will cancel out, and the du will be equals to 3 dx. We have that dx in our integral. Let's make dx the subject of the formula here. So we divide both sides of the equation by 3, and now we have du divided by 3 equal dx. So in the place of the dx, we will substitute du over 3, and in the place of the 3x plus 1, we substitute u. We have the integral of 1 divided by 3 multiplied by u in the place of the 3x plus 1, minus 2 divided by u squared plus 20 divided by 3 multiplied by 1 divided by u raised to the power 3 in the place of the 3x plus 1, and in the place of the dx, we substitute du divided by 3, since it's equal to the dx. We can rearrange before we can integrate. So we have the integral of 1 divided by 3 multiplied by 1 divided by u minus 2 multiplied by, so that u squared, we move it from the denominator to the numerator. The exponent changes sign to negative 2 plus 20 divided by 3. That u to the power 3, we move it from the denominator to the numerator, and the exponent changes sign to negative 3. Also, we can take that 1 over 3 out of the integral. So we have 1 over 3 out of the integral, and the du. Now we integrate with respect to u. So we have 1 over 3 into 1 over 3. The integral of 1 over u is equals to the ln of u minus 2 multiplied by the integral of u to the power negative 2. Negative 2 plus 1 will be equals to negative 1 in the exponent, and we also divide by negative 2 plus 1, which is negative 1, plus 20 divided by 3 multiplied by the integral of u to the power negative 3, which is u to the power negative 3 plus 1, and negative 3 plus 1 is equals to negative 2. We also divide by the negative 2 plus the constant c. Let's simplify. So we have the 1 over 3 multiplied by, so 1 over 3 into 1 over 3. And let's substitute back. So in the place of the u, so we have ln u. In the place of the ln u, we substitute back the 3x plus 1. 3x plus 1 in the place of the u. The negative 2 divided by negative 1 will be equals to positive 2. We also move the u raised to the power negative 1 from the numerator to the denominator. The exponent will change sign to positive 1, but the u is equal to the 3x plus 1. So let's substitute the 3x plus 1. And the positive 20 divided by the negative 2 will be equal to negative 10. So we have negative 10 divided by 3. We move the u raised to the power negative 2 from the numerator to the denominator. The exponent will change sign to positive 2. But the u is equal to 3x plus 1. So we substitute back the 3x plus 1 in the place of the u. Plus our constant c. So let's just simplify this. So we have 1 divided by 3. So we just clean it out. 1 divided by 3 into 1 divided by 3 multiplied by the ln of 3x plus 1 plus 2 divided by 3x plus 1 minus 10 divided by 3 into 3x plus 1 all squared plus c. And if you like, you can distribute that 1 over 3 inside the parentheses. And friends, this will be our answer for question 3.1.